All right. Julie, we're good to go?
We're good.
Oh, okay. All right. Well, you know what I was thinking. All right. Well, good morning, everybody. Thank you for joining us on this hot Thursday morning. My name is Brooks Blakey. I am the Director of UAV Solutions for Earl Dudley in Birmingham, Alabama. And we're just going to take a few minutes to showcase one of the newest features that GeoCue has to offer in their product portfolio, and that is TrueView's LP360, their AI cloud classification. Unless you're living under a rock, you probably have heard a lot about AI lately. That seems to be the buzzword. Everywhere we turn, we're hearing something about AI, and it is making its way into LiDAR point cloud classification. And LP360, or I'm sorry, the engineers at GeoCue created just an outstanding AI classification tool. And if anyone out there is maybe struggling with point cloud classification, or maybe gets a little bit behind, I know we all do sometimes, this could be a possible solution for you. So just what we're going to do is I'm just going to go over a little bit about the LP360's AI ground classification. I just talk about that a little bit, why, you would maybe want to consider that versus the traditional methods of classification. Just kind of highlight some high level details on that. And then just give a really kind of a brief overview or workflow, so to speak, of actually how you execute the AI cloud classification here in LP360. So I'm sharing my screen. Everybody should be able to see the sample point cloud that I have on the screen. And we're going to go over the actual workflow, just kind of do a comparison between how the AI tool works against traditional classification, do a quick control point analysis, and then open it up for any questions that anyone may have. So first and foremost, why would anyone want to even consider AI cloud classification? And when it first came out, in all transparency, it was really something I didn't think I'd be that interested in until I actually started using it and saw just how well it really works. So through LP360's extensive beta testing over the past few months, or maybe even beyond that, this classification tool has really stepped up. It works on virtually any types of data. It does not have to be data captured by a TrueView sensor. It could be a photogrammetric point cloud. It could be a point cloud using with a terrestrial scanner. I mean, any point cloud that you have, you can use with this classification tool. So you don't need trajectory files or any other data outside of the point cloud. So that makes it really worthwhile as well. The other reason why I would think most people would want to consider this is it's just really an effortless workflow. You're going to see, once we go through the sample workflow, just really how easy this is. I mean, I could teach my six-year-old how to do this. It's just that easy. I mean, they've really, when I say they, I'm talking about the engineers at GeoCue. I mean, they've really come a long ways with just making this just so simple that virtually anybody can do it and get a pretty remarkable classified point cloud with virtually no effort behind it at all. The improved classification accuracy has really, the classification accuracy has really improved significantly over the past year or so. It's really reduced false positives, which are non-ground points, which are incorrectly labeled as ground, and false negatives, which are ground points incorrectly classified. So when looking at how much it's improved, it hasn't just improved with certain types of landscapes or features. It's really stepped up and improved when using in virtually all types of challenging environments, complex terrains, dense vegetation, you name it. This tool is something that you could use. Probably one of the best features about it is really there's no training required for this at all. If this is your first time actually seeing this, when I go through the workflow, I think you're going to be pretty shocked at just how easy this really is. Another reason why I think many people would consider this is it's just going to make your workload that much more efficient. For those of us that do a lot of point cloud classification or a lot of point cloud processing, it can really take up a lot of resources on your computer. Some of these data sets, by the time you get finished going through the entire workflow, you could easily have 200, 300, 400 gigs of data in just one project folder. Well, this will virtually eliminate all of that. Everything is done in the cloud. So it's just going to make it that much more efficient. So having said that, I'm just going to go ahead and just kind of jump right into it and just give a really quick demonstration of how this works. So here on the screen is LP360, and we just got a simple point cloud up right here. And this data was captured using the TrueView 540. Not a huge project. Let's take a look here. Only about 18.5 acres, so not that big at all. But there is some rolling terrain back here in the back. You can see it is a new subdivision. You can see the house pads right here and the new homes going up. And then once we have the actual ground classified, you'll see it's actually, there's, I think, about 50 or 60 feet of relief back here. And over here, I think, is a 40 or 50-foot hill. So quite a bit going on here. So what we're looking at right here, right now, is in the workflow, the data set has already been georeferenced, and we ran the strip adjustment to line up any sort of, to correct any dynamic error that may be that might have been present in the trajectories. So that's where we are in the workflow. Haven't done anything else. Haven't done any classification. Haven't done any corrections or anything. So the next step that we would normally do is we would just go ahead and run our corrections against our control points. You can see here are our check shots. So I did use the accuracy star with this data set. You can see we got the accuracy star set up right here. So we're going to tie this into the accuracy star, and everything else will be used as an independent check shot. So I just switched over to the corrected, or some may call it a debiased point cloud. I went ahead and tied it in as closely as possible to the accuracy star. And we're going to go ahead and run this control points report one more time. And the reason why I'm going to do this is when I do the demonstration of the AI classification tool, we're going to run a measurement or the accuracy assessment of the AI classification against doing the classification traditionally. So in preparation for this webinar, not only did I go ahead and put the turkey in the oven and get the AI point cloud processed, but I went ahead and processed the data set on my own traditionally, and that way we can see how the accuracy lines up. Let's go ahead and open up our control points report. I'm going to turn off our control. Just double check our settings. Looks good. And just in the interest of time, we're just going to look at the vertical. All right, there we go. So with the 10 independent check shots that we have placed evenly throughout the project, we have an overall vertical of just under a 1/2 inch, with our standard deviation right at around 100th of the mean error, just a tad higher than that. So I can look at this and tell that we have an equal distribution of error, which is what we always want. So we have a good data set in terms of, or in relation to these check shots when looking at it and with the vertical perspective. Just real quick, what we can do is we can go over here, turn on our intensity. Let's just kind of see, just get a quick cursory view. You can see everything's lining up pretty good. All right, so this is the point cloud we are going to send to the AI cloud. So the first thing we want to do is we don't want to do anything. We don't want to smooth it. We don't want to tile it. We don't want to do the classification. We just want to send it as is. So just double check, just make sure nothing has been classified. You can see still has not been classified. The next step is we're just simply going to go to our ground classification here in LP360. And we're just going to click the AI classification tab. And here we can select the point cloud we want to run the AI classification tool. And this is the one that we would run this on. Okay. Next thing that we are going to do is in the cloud, it is going, in addition to classifying it for us, it is going to classify any outliers, run the smoothing point cloud task, delete any noise classes, and it's also going to tile it. Now, one thing you do have to do, a little bit of thinking, it's not just total plug and play, so we've got to count on our fingers a little bit, is we do need to determine a tile size, and it's pretty easy. So when it comes to running the AI classification tool, the max LAS layer or the max file size each of the LAS layers can be is 3.5 gigs. So let's say you've got a LAS layer and it is 5 gigs. Obviously, that would be too large for it to run just on that one LAS layer because 3.5 gigs is the largest. So what you would do in that case is you would just pull out your measuring tool right here, and you would just measure the point cloud. So in this case, since we've got multiple flight lines, we would want to measure our longest flight line. So if you have a point cloud that's 5 gigs, that exceeds 3.5 gig max size, and let's say you measure the longest flight line and it's let's say it's 500 feet. Well, if you split that in half by make it 250, that would now split that 5 gigs down to 2.5 gigs. So you're now under that threshold. So what we're going to do in this case is we're just going to do the same thing. We're just going to measure our longest flight line. We're just going to break this up by point source ID. Is about right there to right there. It doesn't have to be perfect. So we'll just say 1,300 feet. So what I'm going to do is, again, just really unsure what tile size I am going to use. I've done quite a few tests on this, so to speak, and after speaking with some other customers that are using it, and speaking with some of the guys in tech support at GeoCue, just take your longest flight line. In this case, it's 1,300 feet, divide it by 4, and that would be the tile size that you would use. So in this case, we are just going to set a tile size of about 325 feet. So all we need to do is enter 325 right here for our tile size. Oops. Give it a name. Give it something really, really unique like AI classification. Now, you've got another option here that says keep existing classes. What that means is, let's say if you did start any classification before you send this, if you check this, it's going to basically just keep those classifications and run it based on that. It's still going to run the ground classification. It's still going to give you a classified surface, but you just may have some arbitrary filters, whatever you might have had been classifying to. So just keep that in mind. I'm going to turn that off. Hit submit. And that's it. It's going to go up into the cloud. And what we're going to do is we will get a notification. So I'm going to get an email notification saying that it's been submitted. And then when it's ready, I'm going to get an email notification saying, hey, your AI classification last layer is ready to go. All in, just kind of giving you an idea as far as time, how long it takes. With each of these processes, probably with the classification itself only takes maybe 5 minutes. This is what can take some time. I want to say with this project right here, I think it took right around 30 minutes or so, 30, maybe 45 minutes. Like I said, I've already got the, in preparation for this, I went ahead and processed it and downloaded it. And here is the actual AI classification. And I'm actually streaming this from our cloud drive. And if you're not familiar with that, when you are, we have a point cloud that's actually in the cloud, you don't actually have to download that point cloud to view it. You can just stream it, get your streaming link, then just go into LP360, click the cloud tab. I'm sorry, the cloud tab, then the add cloud layer button. Then you're just going to hit this little green plus. And then you would just enter that streaming link right there. That's all you have to do. So that's actually what we're looking at right now. Is we're streaming this off the our cloud drive. Okay, so this is what we received. Go ahead and force 100%. There's a little lag because it's streaming, but what I just wanted to show everybody in attendance is just some of the point cloud tasks that it does run. So if you're familiar with the LP360 workflow, you're familiar with the smoothing point cloud task, and this is something that it does do for you during the classification. So we can go ahead and we're going to, oh, here it is. So there's the smooth. Oops, messing with it. This is what we sent the corrected. So this is a corrected layer we uploaded, and this is what we received from the AI classification. Let's go ahead and see how it did. Actually, again, I did this classification myself just to do a comparative analysis. Let's go ahead and see how that one turned out. So again, just as a see how it compares against traditional classification, I did this myself. And I use the standard LP360 workflow. I created a seed surface. Well, let me back up. I ran the low point noise filter. I went ahead and smoothed it, created my seed surface, thinned it out, then ran the adaptive 10, ground. Just lost my train of thought. What is it? What kind of test called? The adaptive 10 point cloud test, and then where we run the iterations. That's right. And that's all I did. I didn't do any cleanup work. Didn't go back and adjust anything if I had false positives or anything like that. I just wanted to see how it ran. Try to make it as the comparison as equal as possible. So that's what we're looking at right now. This is the traditional ground classification, again, using the standard workflow in LP360. Go ahead and turn on our contours. You see there is a little bit of work that still needs to be done. I can see there's some cleanup that needs to be done right there. Turn on our points. It's going to be a lot easier to see. There we go. So yeah, I still running this traditionally. I still have a good bit of work to do. There's some cleanup that needs to be done here along this. This is where it's a pretty steep steep is out. It's about 30 feet, give or take. But right there, you can see I missed that part right there. So a good bit of cleanup work needs to be done there. Houses didn't do too bad, but probably have another 30 minutes, give or take, before this will be ready to go. So let's see how that compares to the AI classification. Here's the AI. Contours. We're going to set up our interval at 1 foot. And let's go ahead and turn on our points to see how much cleanup needs to be done. You see it picked up this slope right here. Down here, it picked up a lot of that where I missed that. It's going to come over here. No, I'm sorry, over here. I know there's this hill over here. So there's the AI. Let's see how that compares against just traditionally. Yep. So this is the traditional classification. You can see there's some cleanup that needs to be done all along the base of this hill. You see on the other side, there's some more vegetation over here. Right in here. There's the traditional. Let's compare that to the AI. They both look to be about the same in that area. And the row with curves and everything through here. Let's see if the traditional missed anything. Oops, that's the wrong one. There we go. Yeah, so there's definitely some more cleanup that needs to be done when classifying this traditionally. So if you're paying attention with the AI classification, we didn't have any cleanup work that needed to be done over here. Whereas with the traditional, nothing major. This didn't take too long to clean up, but it just goes to show that the AI tool does a really good job with that. With the algorithm they use. But what everyone just loves to do is the manual cleanup. I know I speak for everybody when I say that. And the biggest thing that we want to see is just, good Lord, is there much more vegetation we need to go back behind and clean up. And if we switch back over to the AI, I just really want to point out, by doing this traditionally, there's still a good bit of work that needs to be done with the cleanup. We go over to the AI. We can see not only is there not as much cleanup that needs to be done, but if we go to our 10 view and turn on our contours, it did a remarkable job of getting all the vegetation. In fact, I don't really see anything. There might be some low points here. Let's take a look at that. A little bit, but yeah, there's some low point noise there. A little bit of cleanup that needs to be done there, but you can easily run that low point noise filter and get rid of all those guys. So definitely less work that needs to be done with the AI. All right, so we can see that it actually does a really good job with the classification. Let's see if it's accurate. So we ran the accuracy report on the point cloud before we sent it to the AI. And I think it was around total RMSE of around just under 400, if I remember correctly. So let's run this on our AI cloud and see what we get. All right, so we got our AI cloud, our AI LAS layer open. Go ahead and open up our control points report. We turn off our control point. Just run this on our independent check shots. Just double check our settings. Looks good. And let's go ahead and run it. All right, so while we're waiting for my computer to stop embarrassing me by slowing down, I'll go ahead and just speak to what, if you are interested in the AI add-on, how it works, what it costs, what you get, all that fun stuff. So the AI classification tool is an add-on, so it would be just like some of the other add-ons that GeoCue offers. It's a subscription license, and I want to say it's like right around $1,500–1,600 a year. And with that, you get, I believe it is 5 classifications per month at no charge. Beyond that, it just comes down to their traditional token system. So think it is. I think it's not $1 an acre. I can't remember exactly how much it is, but I do know you get a minimum of 5 free basically projects each month. I'm not aware of any cap on that. I've got a number of customers already using this. Some have been processing like 300 or 400 acres, and they're able to use that against the allotment that they get each month. And of course, it just can't go seamless.
Brooks, we do have a question. Is there a demo trial that they can try before they purchase?
Yeah, just whoever asked. I don't have Teams open, so I'm just looking at LP360, so I can't really see anything. But whoever asked that question, if you just want to shoot me an email after this, we could probably work something out. I know that GeoCue will offer demos on virtually all their products. There are a couple of exceptions, so just shoot me an email. It's bblakey@earldudley.com, and we'll see if we can get you up and going on that. But again, I'm not sure if you're already an LP360 user or not, but if you're not, we can also get you a trial license for that as well. But just please shoot me an email and we will get that going for you. Of course, something here had to happen. Okay, fun stuff. The magic button, Control-Alt-Delete. Let's see if we can get this going. Of course, it's not responding. Okay. All right, our cloud layer is still there. There it is. Now, I'm not going to force 100% of the points this time. That is probably my fault what I did that. I forgot I had that force, so I'm going to turn that off. All right, let's give this another whirl. Control points, accuracy estimation, turn off. Our survey nil, double check our settings. All that looks good. Oh, yeah, I forgot about this. So when I sent this into the AI to get classified, I don't know what I was thinking, but I sent something to Rail, no clue. And when I downloaded it, I was thinking, oh, great, I messed this up. I have to rerun the whole thing. And as you could see through the results, really didn't have any impact at all. We were still able to get our ground. So that's kind of gives you an example of what's going to happen if you choose the, I believe it's keep existing classifications when you send it. So wasn't paying attention, had that checked, and that's why we're seeing that now. All right, so should be good to go now. Let's see. And this cloud tool is just not going to run. Let me see if I've got this. Julie, were there any other questions?
No, there wasn't.
All right. May need to See if we've got this actually saved instead of streaming it. I think that stream is what's causing this. Causing this to slow down. Let me see our Neptune's code. Here we go. That's it. Where did you go? All right, I think that's it right there. All right, I think this is it. Try this one more time. If not, I'm going to go hide under a mountain of shame. Streaming can be a nice tool, but using it to run your control points reports, not so much. Not so much. I believe I've got it saved, so I should be good. I think this is it. And yes, unfortunately, I was up late last night. Okay, so and last box. I think we are good to go. Yep. Okay. I had it on my computer all along. All right. Okay. So to confirm, the slides layer 1 is the AI classified point cloud. And we're going to get rid of this cloud layer. That guy is cramping my style. Control points. There we go. There you go. So I think the vertical, I think on the traditionally processed, I think it was 0.033. So I know we're splitting hairs there. And I do know we did not have one of the points outside the 90% confidence interval. But we're really kind of splitting hairs when we're looking at these types of numbers. So the overall accuracy is it's right it is hand in hand with the traditionally classified point cloud. So not risking any sort of accuracy or precision. If you look at our mean error, I know our mean error is a little less. Now, the mean error for the traditionally processed was 1400s. This is 1000s. Again, I know we're splitting hairs. But if we are looking at it from a quantifiable perspective, it definitely is a little more precise. So no issues with accuracy, no issues with precision. Obviously, through the comparison, we can see that it is there's a phenomenal job with not giving us any false positives. Don't have to do nearly as much cleanup work, and it's just going to make the entire workflow that much more efficient for anyone who is going to be doing any sort of point cloud classification. And if you're doing a lot of it, you know what I mean when I say this, it's really going to free up a lot of your resources. With all this living in the cloud, it's just going to make your life that much more enjoyable, so to speak. So the last thing I kind of skipped over this is, so when you send up to the cloud, like I mentioned, you will get an email notification saying when it is ready. So once you get that notification, all you need to do is go to your job manager. You see, I've got something right here. You'll just see whatever is ready, highlight it, click complete job. Well, it's not going to let me complete it. This is a different project, but I don't think I have any. Nope. All you need to do is hit complete job, and it will automatically import the point cloud into your project and download to your project folder. So you don't have to worry about any of the streaming or anything like that. We get a little better view now that we're not streaming this. We go back to the ground. So we can see with the, again, we're looking at the AI classification tool. We can see it's still picking up a lot of details on the surface here. I don't know what this was over here. Looks like a truck or something driving through. Pick that up great. I don't know if that's vegetation or cleanup that needs to be done, but we can inspect that real quick. Yeah, not bad at all. Really good job. Maybe some erosion right here. Picked up those features really nice. Again, comparing that to just a traditionally. So this is the one that I did just traditionally. I didn't get anywhere near the detail as the AI did. Matter of fact, if I didn't run the AI, I would not know that there's a big washout area right here. Go back and look at the AI. It looks like that's some erosion or something, but at any degree, that is LP360 AI Classification 101. Under an hour, perfect. Any questions?
There's no questions, Brooke.
All right. Okay. Well, everyone, thank you for joining us this hot Thursday morning here in July. If you got any questions, I'd like to follow up. I do know somebody was asking about a trial. Please just shoot me an email. We'll get you going on that. Should anyone else have any questions about this or anything else LiDAR related, please reach out to us. We are happy to help however we can. With that, I'm going to go ahead and sign off. And I hope everybody has a great rest of the week and try to stay cool. Thank you.
Thanks, Brooks.